Hello my friends, welcome to channel again. And today in this video where I'm going to show you an actionable AI. Imagine a situation that the all cameras which being put on the street are capable to detect car crash, as you can see in this video. You know, for making it more reliable, I actually put some delay on the video. Let me minimize the delay and show you clearly how it look like, and decrease the font size to 2, and reducing the delay up to 0.4 seconds, and run. So guys, as you can see here, there's a car crash is being detected by the camera and showing car being crashed. And here you can see, oh sorry, let me run the program again. So how, the question is how camera is capable to detect accidental area, and how you can make such an algorithm is really simple. This algorithm is powered by AI and the dataset is open source available. The dataset link is being given on the discussion section of the video. So guys, here you can see the crash is being done here. This footage is taken from internet, and this accident is recorded at the year of 2016. It happens sometimes when the crash is being happen, and the time of arriving and notifying by the nearby station is really high, and instead in that precious time we can actually save lots of people, and the person who is going through the pain and injuries can be saved. So this algorithm is also capable to detect many other type of actions like car crash, falling, hitting, kicking, neutral, running, sitting, stealing, and vandalizing. Let me show you one of the sample video, and then we will move forward that how what the algorithm is look like. So let's say there is a slow version of the video I'm going to run. You can see here it is capable of detecting camera will show the notification that people are walking here. Sorry. It automatically label whatever the action is going on the street. Let me make this process a little bit faster to save your precious time. Let's run this model. Like guys, you can see it's showing walking on the top, neutral. This is the very initial version of model, and I have just created and trained it in a very short period of time. Additionally, it keeps showing whatever the things going on the street on the top side. Here you can see a person is hitting, so camera is showing that there is a fight going on, and I guess this video is captured on some store. Like here you can see a person is kicking and camera is showing the person, and that there is a, and here you can see the stealing is also captured by the camera. So there are many action which is which can be captured by the camera, and if such camera is available at your door side, you will get notified, and the same signal will go to the police station, and police can save lot of money, lot of people, and ambulance will come on time as well. So this is all about running code. Let me show you how the code is working. This is an implementation workflow of OpenCV, and the model is trained on the top using keras in TensorFlow 2 at the core side. This is the architectural layout of the model. Uh, Let me stop this video for a time being, and let me show you the total trainable parameter I am used here. Takes few seconds to get complete. Meanwhile, I'll show you there are total uh, 10 convolutional layer of neural network, and in each iteration the number of filter keeps on increasing. Dimensional keeps on reducing with the help of max pooling and stride size. Pool size 2 means the output dimension will be divided by the 2. Drop out 0.25 to avoid the overfitting. Flatten to linearize the vector so that I can train my model corresponding to 10 classes. Input image size by default is 224, and total trainable per parameter I have used here is 42 million. These trainable parameter little bit more than the parameter used in VGG16. I have used such a high complex model so that I can get good accuracy, because when we talk about the actionable AI, which is the next future of AI, and people are so many big organization and people working on this domain, and so I need to show something relevant and good that we can also with a local computer can achieve good performance of model. Once the model is being trained using the data set, that trained model will be saved in the form of PB that can be loaded in a very quick manner in TensorFlow. And once the model is being loaded, there's a built-in functionality in TensorFlow 2 that tf.save model, and we need to give just the path of the folder. Inside the folder, the TensorFlow itself traverses and find out where the model is being kept. As you can see here, here is the model is being placed. Save model. Every time whenever the model is being loaded, we need to find out the local signature where we can feed the input image. Maximum time the input can be input path and input layer path can be saved as if we don't mention any specific name in serving default. Once we get the serving default signature, all we need at what size of image we have used for training our model, the input image is reload with the video, and after loading the video, the frame, we need to binarize the frame with the help of dividing it by 255, convert into tensor so that process and the streamline can become fast. And once it converted into tensor, image will fed to the infer and output get. Once the output get, the output clear, which will be dense one containing the prediction and maximum value of that vector containing the 10 uh, values, and the maximum out of those 10, which will be the maximum value corresponding index, will give us what the activities will be signifies. At the beginning of the video, I have shown you how in a way, how slowly you can see that how the model is looking, how the each input frame is being labeled with the corresponding action. Now I'm going to show you there is a faster version of this execution, and entire, by I've given the request access because this version is not available open source till now. We have kept it for some user only, not for everyone. So all you need to do, just made a request uh, through WhatsApp or email ID to us, and we will let you know how you can get the access of these pre-trained model and the weights. Let me run the video for you and then end up this video for today. So slow video, and let's run. So guys, this is how actionable AI will look like. You can see this process, this execution is really fast. Let me run the video again for you guys. That's why at the beginning I actually make a pause so that you can see every frame and every action in the video. This is all about today, and that's how actionable AI look like. If you have any query and working on the same domain, please ping me. We provided various type of services in thesis, research work, and creating POC. This is RIS, and thanks for watching the video. Bye bye, friends.